Hi, welcome to the Shiko Math Lab Differential Equation Problem Solving section. For this video, I like to revisit the problem we solved in the before. When the time we solved this problem, we use a reduction method. As you can see, this is our notes. All right, so it's pretty heavy, kind of the algebra. A lot of algebras here. So what I like to do is here, instead of using reduction methods here, now for today, I'm going to solve this problem by using Abel's formulas here. All right, so let's go ahead and start so we can compare what is the big differences here. All right, so here. So the first, let me write it down. What is the Abel's formulas here? So if we have a second order homogeneous differential equations, so let's see here. So this is the PT, and this is y prime plus qt, so y equal to 0. Okay, so if I can write these ones here as change my second order differential equation to this form here. So if for given y1, okay, so for given y1t is the solution of this differential equations, right? Okay, of these differential equations. So what is Abel's formula? Will be, so according to Abel's formula, they said the second solution y2t, all right? So second solution y2t will be y1t times the integrations, and here this will be y1t squared. Then the top here will be e, take the integration of negative pt dt. Now overall, I integrate it to the dt. Okay, so now this is the formula we're going to use. So now let's take a look at the differential equations we are dealing with here. All right, so the differential equation we have for this problem is t squared y double prime plus ty prime and minus y equal to 0, and they give us the condition t greater than 0 here. All right, so now in order to change it to this form, the homogeneous form, so let's divide by t2 both sides. So I will have a y double prime plus t over t squared is 1 over t y prime minus 1 over t squared y equal to 0, right? Okay, so based on the Abel's formula, we need to have a PT. So where is my PT? This is my PT, right? So this is my PT. Okay, so let's go ahead. So the first things here we say, okay, let's try to take the integrations of the PT. Wow, that's pretty easy. So this will be PT is 1 over t dt. Then this will give me the ln(t) plus c1. Okay, so this will give me the ln(t) plus c1. And the reason why I can t, because they give us a t greater than 0, so I don't need to put an absolute value in front of it. Okay, so then the next things here is that e to the negative pt dt, right? So this will be e to the negative ln(t), and so plus c1. So this will be the e to the negative, the ln. I can move the negative 1 in, so it's 1 over t. then this is E the C1, right? So I can reassign. I will say, okay, this is my constants. So let's say this is another C1s here. Then E and the natural log T cancel out, right? So what I will have, I will have a C1 over, this is just a constant, so I reuse the term. So it's C1 over T here. All right. So now, based on the formula, I'm going to integrating. So this is C1 over T and Y1T the square. So here the Y1T, the problem given us is 2T. So Y1T to the square is what? It's 4T to the square dt. Correct? All right, so now I will have C1 and I'm going to integrate 1 over 4t to the cube dt. All right, so this one is pretty easy to, so it will be C1. So this will be 1 over negative 1 over a to the t the square, right? So plus C2 here. Okay, so plus C2. So I can just FOIL that, kind of the FOIL that ins here. So I can change this one to so this is a negative 1 over AC1. I can code another C1s here, right? So this is my T square. Then plus C1 times C2. I can say it's C2 stars here. Okay, so that is our, see here, so this is just a constant, right? So this is C1 times, I can code this whole constant again to a C1. If you want, you can code this just C1 star. So that's fine. Also, right, you can say C1 star, then this constant times this constant is, I call this C2 star. Okay, so now the last step, based on the Abel's formula, is Y2T will just be what? Will just be Y1T times this. Y1T is 2T, then times C1 star T squared plus C2 star. Okay, so now I can call this one. So 2T, so this is a T. 2C1 star, I can call another C1 star here. Then 2T times C2 here, I can call this is a C2 star T. So this is, I just don't want to have too many. So this one's here basically is a constant, right? So this is just my original 2 times C1 star. So I can call a new C1 star. Then this one's here will just be my original will be the 2C2 star. I can just rename it because it's just constants, it doesn't matter here. All right, so now I need to substitute my initial condition and try to solve it. So Y2T is here. So Y2 prime T will just be negative C1 star, and this is T to the negative 2, right? Then C2 star, the T cancel out, it just be the C2 star. Okay, so now let me substitute the initial condition. So the initial condition is Y2, the 1 equal to 1. So that means I substitute 1 in here. So I will have a C1 star over 1 plus C2 star equal to 1. Now I also have Y2 prime 1 equal to the negative 1. So I can substitute to here. Then I will get negative C1 star for 1 and the plus C2 star, and this one is equal to negative 1. Okay, so now if I can solve this two-system equation. In fact, this is very easy to solve. You add it, so I will get a C2 star equal to 0 and a C1 star equal to 1 here, right? So this is my condition. Then I substitute this to my y2. So what is my y2t going to be? So C1 star is 1, so it's 1 over t plus C2 star is 0 times t, so it's equal to 1 over t, 1 over t, right? So this is 1 over t here. Okay, so see here, okay, so let me highlight this one, and then let's try to compare what we did in the other video. You can see here, this is very brief, very easy, right? So it's very short. And then let's see what we did here. Okay, so we set a plug into the initial value, da 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 da. So we have what is 1 over t here, right? So that's what we got here is y equal to the 1 over t here. Okay, see here? So that's why, I like to revisit this problem by using a different method to let you see, when you choose the correct, not the correct, both of them are correct, but when you choose the methods here, some of them will make your algebra work a lot easier. All right, that's it. Okay, so hope this will help you try to find a different way to solve the differential equation and simplify a lot of the algebra. All right, that's it. Have a nice day, and well, talk to you later then. Okay, enjoy your day. Bye.